Now let's just move on further to the question number 3, which says draw a line segment AB of the length 8 cm, taking A as a center, draw a circle of radius 4 cm, taking B as a center, draw a circle of radius 3 cm, construct the tangents to each circle from the center of the other circle, and we also have to give the justification for this. So let us suppose if I'll start with the construction, and we are starting with drawing a line segment AB of the length 8 cm. So using the help of the ruler, we can draw a line segment AB having the length as nothing but 8 cm. So let us suppose if I'm starting the steps of construction again one by one. So let us suppose if we are talking about the steps. So the step number 1 is like draw a line segment. Draw a line segment AB is equal to 8 cm. This is 8 cm. And the second step would be like we have to construct the circle. As you can see, taking A as a center, we have to draw a circle. So let us suppose if I'm taking A as a center, taking the radius as nothing but 4 cm, using the help of the compass, I am constructing a circle over here. This is my circle. And the next step would be like draw a circle with the radius 4 cm at A, and similarly draw a circle with the radius as 3 cm at B. So similarly we have to draw the circle at B as well. So let us suppose if I have drawn a circle over here at the point B, taking B as a center of the radius as nothing but 3 cm. So now the further step would be like we just wanted to construct the tangents to each circle, to each means to this circle as well, to this circle as well. So let us suppose my third step would be like we have to bisect AB. How we can bisect AB? We know that we have to draw the perpendicular bisector of AB. So let us suppose using A and B as the center, I am forming the perpendicular bisector of AB in such a manner. So the third step would be like bisect AB and call the midpoint as nothing but the point M. So I have taken the midpoint as nothing but M. So the further step would be like taking M as a center, AM as a radius, draw a circle. So draw a circle taking M as a center and AM as a radius. So this is my circle. So this is the circle that is formed taking M as a center and AM as nothing but the radius. I have constructed this circle in this particular form, and now we can see that this circle actually intersects this circle and this circle at exactly 2 points. So as you can see, this point and further we have this point of intersection, and further we have this point of intersection, and further we have this point of intersection. So let us suppose we'll call these point of intersection with the various names, and we will join these point of intersection with A and B. So let us suppose if I'm starting with B and I'm joining this point of intersection and calling it as nothing but P, and further I'm joining this P with this particular point and calling this point as Q. So the next step would be like fifth point, we have to take the point of intersection. So call the point of intersection of the circles as P, Q, and let us suppose I'm taking the other one as well. So this one I'm calling as R, this one I'm calling as S. P, Q, R and S. And the sixth step would be like join AR, AS, BP and BQ. So hence the seventh step would be like AR, AS are the required tangents to the circle with the radius 3 cm, and BP and BQ are the required tangents tangents to the circle with the radius 4 centimeter. So this is nothing but all about the construction of such kind of a triangle. And now let's just justify that whether they are nothing but the tangents or not. So for this, let us suppose if I'll do a little bit of construction. So let us suppose if I'm talking about the justification of this one, if I'm giving its a justification that whether they are the tangents or not. So let us suppose if I'll prove only a single one and then I will say similarly. So if I am doing a little bit of construction that I'm joining this BS altogether. Let us suppose I'm joining this B and this S. Let us suppose this is my joining and this is nothing but a straight line. This is definitely a straight line. I am making it a solid one. So let us suppose if I have joined this BS, now you can see that this is nothing but a triangle that is formed, that is ASB. Now if you can see the angle that is BSA, that is the angle BSA is actually the angle in the semicircle. It is nothing but the angle in the semicircle, and we know that the angle in the semicircle is always 90 degree. It implies that the angle BSA is 90 degree, and if it is 90 degree, so we know that the tangent makes an angle of 90 degree with the radius of the circle, which implies that this AS is nothing but the tangent. AS is the tangent, and similarly all. So if AS is the tangent, it means similarly all are the tangents. We can again do this construction over here. If I'll do the construction over here, I'll join this R and B. Again, this is nothing but an angle in the semicircle. So this is again would be a 90 degree, and we know that the tangent always makes an angle of 90 degree with the radius of the circle. So with the radius of the circle, so this would be again nothing but AR would be a tangent. And similarly, like I did for this particular circle, let us suppose if I'll join this A and P all together. If I'll join this A and P, we can also say this for this AP and AQ again, that they are also forming an angle of 90 degree. This is also forming an angle of 90 degree because this is the angle in the semicircle. Again, this is an angle which is forming an angle of 90 degree because this is an angle in the semicircle. So if this is an angle in the semicircle, this would be 90 degree, this would be 90 degree, and hence if this is 90 degrees, so it means that this PB is nothing but the tangent, and further this QB is again a tangent. This is also a tangent. So all of these are nothing but the tangents using the same justification that I have given for the AS. So this is all about the question number 3.